Welcome back to the next class, sir. Let us see linear programming case 2. This is minimization problem. Last session we discussed about maximization problem, sir. When my objective function is maximization, how to solve the given problem. Now let's go one question with cost minimization problem. Okay. A company has two bottling plants. Question is, a company has two bottling plants located at two different places. Located at two different places. Full stop. The capacities of the two plants, in number of bottles per day are as follows. What is given to you in the question, sir? Capacity of each plant in number of bottles are given. So we have two plants, plant 1 and plant 2. Okay. And it is product A, product B, product B. Look at this. A company has two bottling plants located at two different places. Full stop. Each plant produces three different drinks, A, B and C. Each plant produces three different drinks, A, B and C. Capacities of the two plants, in number of bottles per day. Capacities of the two plants in number of bottles per day are as follows. This is plant 1, this is plant 2. Product A, product B, product C. Capacities are given as 3000, 1000, 2000. Next, 1000, 1000, 6000. Okay. What is given in the question? A company has two bottling plants which are located at two different places. Each plant produces three different drinks, A, B and C. Capacities of two plants in number of bottles per day are as follows. What additional information is given to us, sir? A market survey indicates that during any particular month there will be a demand of 24,000 bottles of A, 16,000 bottles of B, 48,000 bottles of C. Look at this. What additional information is given? During any particular month, there will be a demand of 24,000 bottles of A, 16,000 bottles of B, and 48,000 bottles of C. Operating costs per day are given. Operating costs per day. Plant 1, plant 2 are rupees 6,000, rupees 4,000 per day respectively. Now you have to take a decision, sir. How many days each plant we have to run? Look at the final statement. How many days should the company run each plant to minimize the operating cost while still meeting the market demand? How many days should the company run each plant in a month to minimize operating cost while still meeting the market demand? Meeting the market demand. This is my full-fledged problem, sir. Okay. Look at the question one more time. What is given in the problem? A bottling company is having two plants which are located at two different places. Each plant is producing three different drinks, A, B and C. The capacities of the two plants in number of bottles per day are as follows. Production capacity is also given. After this, look at this: 24,000, 16,000, 48,000. What these figures will represent, sir? These figures will represent requirement, market requirement. During any particular month, there will be a demand of 24,000 bottles of A, 16,000 bottles of B and 48,000 bottles of C. Clear? Now what is the decision here we have to take? How many days should the company run each plant in a month to minimize the operating cost while still meeting the market demand? Clear? Look at the key point here. Operating cost per day of running plant 1 and plant 2 are rupees 6,000 and rupees 4,000 per day respectively. This is also given, sir. Okay. So first step is, let us declare the decision variables. Solution part of the question. Let x1 is equal to number of days plant 1 to operate. Plant 1 to operate in a month. x2 is equal to number of days plant 2 to operate in a month. Okay. x1 comma x2 greater than or equal to 0. x1 comma x2 greater than or equal to 0. So first step is over, declaration of decision variables. Then we have to declare objective function, sir. Objective function is minimize cost. This is operating cost per day of running plant 1 into number of days. Operating cost per day of running plant 1 into number of days plus operating cost of running plant 2. Operating cost per day of running plant 2 into number of days Operating cost is how much given, sir? 6,000 into x1 plus 4,000 into x2. 6,000 into x1 plus 4,000 into x2. Subject to certain restrictions. What are the restrictions, sir? Demand. Product A is having a demand of 24,000 bottles. Product B is also having a demand of 16,000 bottles. Product C is having 48,000 bottles. What will be the consequence if we don't satisfy the demand? Our customers will shift to the next company, other company. Therefore, it is loss of goodwill in terms loss of profit. Therefore, we have to meet the demand, market demand, and a decision should be taken for how many number of days we have to run plant 1 and plant 2. So look at this, sir. First, plant 1 is producing 3000 bottles per day. Plant 1 is producing 3000 bottles of product A, and plant B is producing 1000 bottles of product B. If it is per day's capacity, it should be multiplied with the number of days we decided to operate plant 1. Subject to, how can I write? 3000 into x1 plus 1000 into x2 must be greater than or equal to 24,000. Must be greater than or equal to 24,000. Next, 1000 into x1 plus 1000 into x2 must be greater than or equal to 16,000. Here it is 2000 into x1 plus 6000 into x2 must be greater than or equal to 48,000. Look at this point one more time, sir. This 3000 will represent what? Production capacity of plant 1 for product A for per day. Production capacity 3000 bottles of product A, plant 1 is producing per day into number of days. Day cancel, it is in terms of number of bottles. What is this 1000 stands for? 1000 is nothing but number of bottles of product A plant 2 is producing. Number of bottles of product A plant 2 is producing. This production capacity per day when multiplied with the number of days, day cancel, leaving with number of bottles. So for operating x1 days of plant 1, this many bottles can be produced. Similarly, for this you have to take interpretation. So total production is 24,000. That is the minimum requirement that we have to satisfy. Clear, sir? Now take up this step, sir. Solution. Step number 1. Step number 1, formulation. Formulation. It's over. You take up, then I'll go for the solution. I'll give you 1.5 minute time for you to note down, sir. Now, look at the question one more time. I am eliminating this part from the picture. Let's say this, sir. Minimize cost. This is equal to 6000 into x1 plus 4000 into x2 subject to 3000 into x1 plus 1000 into x2 must be greater than or equal to 24,000. 1000 into x1 plus 1000 into x2 greater than or equal to 16,000. 2000 into x1, 6000 into x2 greater than or equal to 48,000. Okay. Now what is my second step, sir? I have to solve this problem by graphic method. I have to solve this problem by graphic method. So step 2, solution by graphic method. When I am solving the problem, I will consider inequalities as equalities. I will consider them as equalities. So it is 3000 into x1 plus 1000 into x2 is equal to 24,000. 1000 into x1, 1000 into x2 is equal to 16,000. 2000 into x1, 6000 into x2 is equal to 48,000. This way 3 equations we have, sir. Variable x1 I am representing on x-axis. Variable x2 I am representing on y-axis. On x-axis, sir, every y point is 0, and on y-axis every x point is 0. So, to get x1, put x2 is equal to 0 in 1. So 3000 into x1 is equal to 24,000. So x1 is equal to 8. So this is 8 comma 0. What is the interpretation of this 8 comma 0? Here you have a solution. You can run 8 days plant 1, 8 days plant 1, 0 days plant 2. Now to get x2, put x1 equal to 0 in 1. So I will get 1000 into x2 is equal to 24,000. x2 is equal to 24. This is point 0 comma 24. What this solution is saying? Run plant 1 for 0 number of days, run plant 2 for 24 days. Okay. Similarly, solving 2 and 3. Solving 2 and 3, sir. When I solve second one, I will get C 16 comma 0. D is equal to 0 comma 16. E is equal to 24 comma 0. F is equal to 0 comma 8. This way we have points. Next, we have to represent them on the graph. Now what is the maximum point on x-axis? 24. Maximum point on y-axis is also 24. So 4, 8, 12, 16, 20, 24. 4, 8, 12, 16, 20, 24. Now 4, 8, 12, 16, 20, 24. What is the first point, sir? 8 comma 24. 8 is on x-axis, 24 is on y-axis. Joining these two. Joining these two, you will get this way, a line. Second one is 16 comma 16. 16 is C. 16 is here D. So this is the point of intersection of these two. Finally 24 comma 8. 24 is on x-axis, 8 is on y-axis. F. Joining these two. So this way we have three lines, sir. This is first line. 3x1 plus x2 greater than or equal to 16. This is my second line. x1 plus x2 greater than or equal to 16. This is 24. 16. Finally, this is E. Means 2x1 plus 6x2 greater than or equal to 48. 1000 is taken common, sir. I am expressing capacity in thousands, so that is not representing on this one. Now, first we have to identify the common area for the three lines. Our inequalities are greater than or equal to. Since inequalities are greater than or equal to, above the line you have to consider. Above the line you have to consider. Above the line means this area is common. So feasible area is this one. This is my feasible area. Let us take this as G and this as H. Feasible area above the line, common for the three lines, and greater than or equal to sign, therefore above the line. How many points we have, sir? E is 1 point, H, G and B. So let us take for minimization of cost, consider all the corner points in the common area. Consider all the corner points in the common area. So this is corner point. C is equal to 6000 into x1, 4000 into x2. It is in rupees. First point is E, 24 comma 0. So 6000 into 24, 1,44,000, sir. 1,44,000 plus 0. I am replacing x1 with 24. Otherwise, I will write 1 minute. It is 6000 into 24 plus 4000 into 0. Now it is 1,44,000. Next, point B. This is 0 comma 24. This is 0 comma 24, B point. So this is 6000 into 0 plus 4000 into 24. $4,000 into 24. This is 96,000. Now two more points we have, H and G. Now sir, look at this. Point Z lies on 1 and 2. Point G lies on 1 and 2. G lies on 1 comma 2. So this is 3x1 plus x2 is equal to 24. x1 plus x2 is 16. Minus minus minus. 2x1 is equal to 8, x1 is equal to 4. 3 into 4 plus x2 is equal to 24. x2 is equal to 24 minus 12, 12. 3 4s are 12. 24 minus 12, 12. So 4 comma 12. 3 4s are 12 plus 12, 24. 4 plus 12, 16. So 4 comma 12. Similarly, H is on 2 and 3. H is on 2 and 3. x1 plus x2 is equal to 16, dividing throughout by 2000. So x1 plus 3x2 is equal to 24. Minus minus minus. Minus 2x2 is equal to minus 8, x2 is equal to 4. x1 is equal to 16 minus x2, 12. So 12 comma 4. H coordinates are 12 comma 4. So it is 6000 into 12 plus 4000 into 4. 6000 into 12 plus 4000 into 4. 6000 into 12 is equal to memory plus 4000 into 4 is equal to memory plus MRC, 88,000. This is 88,000. Now sir, 6,000 into 4, 6,000 into 4, 4,000 into 12. So 24,000 plus 48,000. So this is 72,000. 72,000. Okay. Now look at this. 72,000 is the minimum cost. 72,000 is the minimum cost. Out of these 4 solutions, best solution is 4 comma 12. Why this is selected, sir? Our objective is cost minimization. When you run 24 days plant 1 and 0 days plant 2, what is the total cost? 1,44,000. When I run plant 2 for 24 days, 96,000 cost is coming. By running plant 1 for 12 days, plant 2 for 4 days, 88,000 cost is coming. Finally, by running plant 1 for 4 days, plant 2 for 12 days, 72,000 cost is coming. So, since rupees 72,000 is the minimum cost, so the company has to run. The company has to run plant 1 for 4 days, comma plant 2 for 12 days in a month to minimize cost, while still meeting the market demand. while still meeting the market demand. Okay, sir. Let's verify whether 4, 12 satisfying this or not. 4 days plant 1, 3 4s are 12,000 plus 12 days, 12,000, 24,000 bottles of A we are producing, sir. 24 is the minimum requirement. So, product A, we are producing only 24,000 bottles. Next, 4,000 plus 12,000, 16,000 bottles. Here also minimum requirement satisfied. Look at the second one. 2,000 into 4, 8,000 plus 12 into 6, 72,000. So 80,000 bottles are produced here. 80,000 bottles. What is the minimum requirement? 48,000. So additional bottles are produced without incurring any additional cost. Okay. So this is the complete solution to the given problem. Cost minimization. Fine, sir. Note down the solution. I'll give you 2 minutes time. Okay, sir. Now, look at the problem number 2 of our CMA material, page number 2.310. Problem number 2, page number 2.310, CMA material. CMA material. This is problem number 2, page number 2.310. CMA material. An an agricultural research institute suggested to a farmer to spread out at least 4,800 kilograms of special phosphate fertilizer and not less than 7,200 kilograms of special nitrogen fertilizer to raise productivity of crops in his fields. Look at the question one more time, sir. The Agricultural Research Institute suggested to a farmer to spread out at least 48,000 or 4,800 kilograms of a special phosphate fertilizer and not less than 7,200 kgs of a special nitrogen fertilizer to raise productivity of crops in his fields. There are two sources for obtaining this, mixture A and mixture B. Both of these are available in bags weighing 100 kilograms of each and they cost rupees 40 and rupees 20 respectively. Mixture A contains phosphate and nitrogen equivalent of 20 kilograms and 80 kilograms respectively, while mixture B contains these ingredients equal of 50 kilograms. Write this as a linear programming problem and determine how many bags of each type should the farmer buy. Underline this point, sir. How many bags of each type the farmer should buy in order to obtain the required fertilizer at minimum cost. So these are available in two sources are available for obtaining these mixtures A and B, and these are available in bags. Okay. Let us take X1 is equal to number of bags of A. X2 is equal to, sir, number of bags of B. X1 is equal to number of bags of A. X2 is equal to number of bags of B. You also open, sir, study material. Look at the question. Now, what is the cost given? Bag A cost rupees 40, bag B cost rupees 24. And the objective is minimize cost. X1 comma X2 greater than or equal to 0. Minimize cost is equal to 40 into X1 plus 24 into X2, subject to. Now you want phosphate fertilizer and nitrogen fertilizer. This we want, sir. And these are available in two types of bags, A mixtures A and B. We have to prepare the inequalities in terms of decision variables. We have to prepare the inequalities in terms of decision variables, sir. First one is what is given, sir. A contains phosphate and nitrogen equivalent of 20 kilograms and 80 kilograms respectively. And B contains 50 each. So, this can be written as phosphate, first one. First one is phosphate. Bag A as well as bag B both are having, let us say, bag A and bag B. This is phosphate. Bag A contains how many? 20 kg. Bag B contains 50. Second one is nitrogen. Bag A contains 80 kg. Bag B contains 50 kg. So this is X1, X2. X1 number of bags of A and X2 number of bags of B. we decided to purchase. And minimum requirement is 4,800, 7,200. This way it is given, sir. So first one is, one bag of A contains 20 kilograms of phosphate. Look at the table, sir. One bag of A contains 20 kilograms of phosphate A. X1 number of bags. This many number of bags we are purchasing. So this is 20 into X1. From bag A, this is the total availability of the phosphate, and 50 into X2 must be greater than or equal to 4,800. Must be greater than or equal to 4,800. Next, nitrogen. From one bag, 80 kilograms are available. 80 into X1. And one bag of B contains 50 kilograms. 50 into X2 must be greater than or equal to 7,200. This is what? Formulation. This is what, sir? Formulation of the given problem. Now, we have to solve this. When formulation is over, we have to solve this. Make it 1, this is 2. To get X1, put X2 is equal to 0 in 1. To get X1, put X2 is equal to 0 in 1. So 4,800 divided by 20. This is equal to 240. A is equal to 240 comma 0. To get X2, put X1 is equal to 0 in 1. So this is 4,800 divided by 50. This is 96. So this is point B, 0 comma 96. Similarly, solving 2. When I take X2 as 0, 7200 divided by 80. X1 is equal to 90. C is equal to 90 comma 0. Now D. For getting D, sir, put X1 is equal to 0. D means X2 value. 7200 divided by 50. 144. 0 comma 144. 0 comma 144. Okay. Now let us represent them on x-axis and y-axis. 96 is divisible by 12. 144 is also divisible by 12. So on y-axis, we will take the numbers which are multiple of 24, and on x-axis they are multiples of 20. So this is 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. On x-axis, maximum point is 240. On y-axis, it is 144, 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144. 140. Okay, sir. What is the first point? 240 comma 96. 240 is on x-axis A. 96 is on y-axis B. Solving these two. joining these two, you will get a line equation. Joining these two, you will get a line equation. This is 20x1 plus 50x2 greater than or equal to 4800. What is the second point, sir? 90 comma 144. 90 means C, 144 means D. This is point of intersection E. Now once again, identify the common portion and shade it. Your inequalities are greater than or equal to. Your inequalities are greater than or equal to. Therefore, above the line you have to shade and common portion. Above the line and common portion. So this is the solution area to the given problem. This is the solution area. Now, I know point A, I know point D, I need E. Since E is on 1, 2, solving. 20 into x1 plus 50 into x2 is equal to 4800. 80 into x1 plus 50 into x2, this is equal to 7200. Subtracting one from the other, cancel. Minus 60 into x1. This is, sir, 4800 minus 7200, 2400. Minus 2400, x1 is equal to divided by 60, 40. So if I substitute in line number 1, 4800 minus 800, 4000 divided by 50, I'll get 80. x2 is equal to 80. So E coordinates are 40, 80. Now all the points we have. So corner points, this is working part. Corner points, C is equal to 40 into x1 plus 24 into x2, C in rupees. First corner point is 240, 0. First corner point is here 240, 0. So this is 240 into 40, 9600. So 40 into 240 plus 24 into 0. This is equal to 9600. Second one, 40, 80. This is second point E. 40, 80. 40 into 40 is equal to memory plus. 24 into 80 is equal to memory plus MRC. 3520. 3520. Next, D. This is equal to 0, 144. 0, 144. So this is 24 into 144. 3456. 3456. So this is the minimum cost, sir. Solution is 144 bags. 144 bags of B he has to purchase. 144 bags of B he has to purchase to minimize the cost. Let me check up calculations one more time to be on the safe. 40 into 40, 1600. 40 into 40 plus 24 into 80. 3520. So 144 will represent bag B. 144 bags of B the farmer has to purchase. To minimize his cost. Okay, sir. This is the problem, solution to the given problem. Now it is a complete solution to the given problem, sir. Note down the solution.